This is lesson 7.6, law of sines. So law of sines is very useful for finding angles or sides in any triangle, not just right triangles. It says that the ratio of the sine of an angle in a triangle and the side opposite is equal to the ratio of the sine of another angle over the side opposite of that angle. So for example, here we have sine of A, so angle A, is over little a. So A goes with A, so the angle goes with the length of that side. Then we have the sine of B goes with B. B and B go together. And then lastly, C and C go together. Now the ratios of all of those are the same, which is pretty cool. And we're always going to use sine. That's why it's called law of sines. So now what we're going to do is we're going to use law of sines to find the length of DF. So here, if I'm looking to find DF, I'm going to put an X here. And I'm going to look at my triangle. So here's how we set up law of sines. We always start with sine of an angle. So I'm going to pick this angle 44. So the sine of 44 goes over its opposite side. Then in my other ratio, again, I always use sine, but now I'm going to pick another angle that I know, sine of 80, and I'm going to pick its opposite side, 20. Now I'm going to cross multiply. 20 times the sine of 44 is equal to x times the sine of 80. Now to get x by itself, what I would do is I would divide both sides by the sine of 80 so that these cross out. And now in my graphing calculator, I'm going to use alpha y equals and type this in exactly how you see it. So 20 sine 44 over the sine of 80. And that is your value for x, which is 14.107 for ... All right, we're going to try it again. Now we're going to use law of sines to find mn. So again, we're going to put an x here. I want you guys to go ahead and set it up. You're going to find an angle and a side that go together, and another angle and another side that go together. So I'm going to scroll out so that you can see my work. And I'm going to give you a few seconds to try it yourself. Now, why does my ratio look like this? Because I'm finding an angle and its opposite side, and I'm finding another angle and its opposite side. Now, once I've done that, again, we're going to cross multiply and just solve. Go ahead, give yourself a second to do that. All right, did you get 16.0605? Oh, well, Mrs. Murray read the question wrong. I thought I did. I was confused. Cross this out if you're following this video and change this to LN because we were supposed to find this side, which we can, but I just accidentally made a mistake and I don't feel like redoing my video. All right. Here we have a word problem. You can go ahead and try that if you'd like. It's the same as what we did up here. The only change here, actually, there is a small difference. Here's the difference. When I go to do this with law of sines, I'm always going to find an angle and its opposite side. So I know that one of my ratios is going to be the sine of 20 over 58.4. Now, the issue with this one is that I need to find x. X is down here. So the problem with this is that the 94 does not go with x. 94 is actually goes with this longest side of the triangle. So in order to figure out how to get x, I'm going to need to find another angle. And I need to ask myself how I find a missing angle of a triangle. Well, I know one angle in my triangle is 20, the other is 94. If I add those together, I get 114. Then what can I do with that 114? I can subtract it from 180. So 180 minus 114 gives me 66. So now I know that angle that goes with that opposite side. Now I want you to think about this question. From his location, Rick sees the angle of elevation to the top of a monument to be 15 degrees. So I'm going to put 15 here near Rick. And I'm going to just transfer it down because I've already redrawn that triangle. Kate sees the angle of elevation to the top to be 20. So here's Kate with her angle measure. If Kate and Rick are 100 feet apart, how tall is the monument to the nearest foot? So all I'm going to do to start is to recopy everything with my triangles drawn out separately, just like I always do. The only problem is that this time, because I'm only given a part of a triangle, I'm going to redraw that tiny triangle. I am not going to redraw the really big triangle that I highlighted in yellow. My yellow doesn't make sense. Instead, I'm going to highlight this little bitty triangle here. Boop, boop, boop. Oh, let me highlight it. I'm going to need to find this triangle. Otherwise, the 100 is not a side of any triangle, and that's a problem. So in order to do this question, we're going to need to do something first, because right now there's nothing I can do. In this triangle over here on the right, I can't do a whole lot. I know that I have a right angle, and I know that this side is X, but that's all I know. I don't know any other sides. In the pink triangle, I only know that one side is 100 and the other side is 15. So the first thing that I have to do when this happens is I have to find its, oh my goodness, we have a linear pair. So I have to find the linear pair of 20. So a linear pair has a sum of 180. So that means that here, this angle is 160. Why is that helpful? Because now if I know that that's 160, I can find all of the angles of this triangle. That tiny angle at the top is now 5. So our steps are now to a label. Then we're going to find all the angles in the skinny triangle. Once we do that, we can use law of sines. Now your question to me is going to be, which side do you need to find? You can find any side that you want, but this side I think is the one that's usually the most helpful. And usually I put a Y there instead of an X. But if I find this side, I can find that side because they're the same side. All right, well, that's the start of how we can use law of sines to find the side of overlapping triangles. But that's actually part of our next lesson. So I'm going to pause this here and go ahead and check out the next lesson.